States area. Welcome to the ESA Junior Faculty Webinar Series, and thank you for joining us today. As always, we'll have two 20-minute presentations, and these presentations will be followed by 5-minute discussions, and if we have time, 5 minutes for questions. As most of you probably know, we will have an after party at the end. In the past, we have used this extra time to ask more questions to the speakers as well as the discussants and have a more in-depth conversation about the papers. Time to time, these conversations lead to discussions to topics beyond these papers, and they may prove to be very useful for especially junior researchers like myself. Okay, that is the after party. Now, let me quickly introduce our first speaker, Lisa Spantig. Lisa got her PhD from the University of Munich in 2018. Currently, she's a lecturer in the economics department at the University of Essex. Lisa does research mainly at the intersection of behavioral and development economics. Today, she'll be presenting us her study, Cash in Hand and Savings Decisions. Lisa, take it away.
So thank you very much, everyone, for joining. Thank you so much for this kind introduction. So it's going to be about cash in hand, and I want you to think about this as literally holding cash physically in your hands. Why am I interested in cash? Well, cash is still the most predominant means of transaction. It might not be true in your reality, but here I bring you a map with the share of the adult population who is only using cash in their transactions. And you see that in particular in developing countries, the color is dark shaded, meaning that a high share of the population is only using cash. So actually there's 56% of the adult population in developing country relying on cash only. And that's not an issue if we are willing to believe that cash is fully fungible, but being behavioral economics, I don't think it's a surprise for you to know that this assumption can be violated. So for instance, when labels are being applied, cash might not be as fungible as we would like. Today I want to focus on something else that might reduce the fungibility of cash, which is the physical presence of cash itself. So the physical presence, not only for cash, but for items in general, has been shown to matter for transaction. So for endowment effects, for example, we know that those are stronger when the goods are present, so people have a harder time giving items away that are physically present. And that also seems to be the case for cash, where in lab experiment it has been shown that, for example, donations are lower when people need to spend it from the cash that they have received at the beginning of the session as compared to virtual currency that they would spend. That's also consistent with the literature and consumer research showing that spending rates are lower when people use cash as compared to cards. So to take away here is that cash is widely used, but it actually can influence decision making. So what type of decision making am I interested in here? The title already gave it away. I'm interested in savings decisions. And in particular, savings decisions where people put money into their savings account, because these savings accounts have been shown to help reduce poverty. So especially in those countries where we've seen that cash use is very high, these savings account can be very beneficial, but we also know that the account use is very low. So for example, 61% of the adult population actually have a bank account, but only 21% of those who have such an account also use it for savings. And that's not because the poor are too poor to save, so they do often have some small amount of money that they could put aside, but they often don't end up doing so. And so what I want to explore in this paper is how having this cash physically present is influencing deposits into those accounts, so can be potentially very beneficial. And as you can imagine, it's very hard to establish causality in the setting. And even if I'm able to causally show any direction of like how cash is influencing savings, it's very hard to get at this particular effect that I'm interested in, this physical transaction. So what I will do in this paper is I use an experiment to create a very controlled environment where I can control for all potential confounds that also influence savings decision. And I will focus exclusively on the causal effect of this like physical transaction of cash and to see how this influences savings deposits. And the main hypothesis I will be testing in this paper is that this physical transaction of cash reduces savings deposits into savings accounts. So there's three literatures this paper relates to. The first one is in experimental economics literature in the lab that shows that behavior with cash physically present is systematically different from behavior with virtual experimental currency, in the line with the main hypothesis, namely that cash reduces donation, reduces spending on, for instance, punishment, and so on. So here I will be providing the first test of this cash in hand effect in a field setting. I also briefly mentioned already the literature in consumer research discussing that cash induces a high pain of paying because the physical transaction makes this parting of money very salient, and thus cash leads to lower spending levels than, for example, using cards. Here I actually test this cash in hand effect in a different domain, namely savings as compared to spending. And then it also, given a setting, relates to development economics, trying to understand why poor people don't save as much, and whether we can do anything to help them overcome the savings constraints. So as we discussed last week, actually in the after party, I will spend most of this presentation on the research design. So let's briefly think a bit about what would be the ideal setting to conduct such a study in. So I want this to be a setting where cash use is high and savings rates are low, using a relevant population. And also I want to be able to hold constant all these other factors that might affect savings, ranging all the way from regulations to transaction costs. And then also I want to have an idea of what people actually save in their real lives. So what I found is the settings in the Philippines where I team up with one microfinance organization and I study savings decisions of microfinance clients who all face the same savings account. And importantly, these people also have loans and they need to meet weekly with their peers to repay the loans with the organization. Now, during these meetings, they can also access their savings accounts. So irrespective of whether they want to save or not, they need to be in the meeting such that the marginal transaction cost of using the savings accounts is actually zero because they are in the meeting already. And then I can link data from my experiment to administrative data on savings behavior. A bit more background on these savings accounts. So everyone, upon joining this organization, receives a savings account automatically and for free. And it's quite an attractive account, bearing 4% of interest if clients have at least a balance of 500 Filipino peso, which is about 2.5 daily wages of this population. So now let me tell you a bit more about the experimental design. So the main idea is inspired by the literature on endowment effect, and it's very straightforward. So people will take part in paid individual interviews, and during these interviews, they will make a savings decision. So from the money that they receive for taking part in the interview, they can decide to deposit some of this money into their existing savings account. So in that sense, it's a real life decision that's implemented in their savings account. I have two main treatments. The first one is cash in hand, which is quite literally that. So they receive their participation payment at the very beginning of the interview, and then they sit through the interview with the cash in their hand or in their pocket. Then during this interview, they're being asked whether they want to save some of the money that they received for taking part in their savings account. If they want to do so, they need to hand the money to the enumerator, who then at the end of the interview will deposit the money into their savings account. So this is really this physical transaction that I'm interested in, giving the money away to put it in the savings account. What's the counterfactual? So this is what I call the cash announce group, people know that they will receive the cash, and I will explain this in 2 slides how it works. So they know that they will be paid for taking part in the interview, but they don't hold this money physically. They go through the exact same questions, and then they're being asked whether they want to save some of the money that they will be paid for the interview. And if yes, they just say the amount that they want to say verbally. And then just after making the savings decision, they receive whatever they didn't save. So at the end of the interview, everyone is left with the participation payment that they did not want to save. So just an overview. So we just discussed this cash in hand variation, which is my main treatment. So either holding onto cash and giving it away, or just saying how much you want to save, and this is randomized between individual participants. I have a second treatment variation that varies how much people receive for taking part in the interview, and it's either 1.5 or 2.5 daily wages. And that's randomized between borrower centers, these meetings in which the sessions take place, and I will explain in the next slide why. So overall, I have this 2x2 fully cross-randomized between subject design with 75 independent observations per treatment. So the overall timing of the experiment is as follows. 1 week before we conduct the session, I send a letter that states that a research team will be coming to the center meeting and conduct paid individual interviews. Then during the session that's conducted during the weekly meeting, we briefly introduce the research team, and then we ask for volunteers who would participate in the interview. Of those people who volunteer, we have a public random draw of 10 participants who will actually take the interview. Only afterwards, we announce how much money they will receive for taking part. So this is to avoid selection into these higher paid interviews. Not only do we announce, but we also show them the bills that they will be receiving, so everyone knows how this money will look like and what types of bills they will be deciding about. And then we start with the individual interviews, so one-on-one with my local enumerators, and then at the end of the interviewers deposit the cash in the savings account. Now, importantly, why would people save? So I have a payment of a match of 20% that is being paid if the amount that people save during this interview is still in the account 4 weeks after the session. So why do I implement this? Well, 3 reasons. The first one is to have a distribution of amounts that people save. So that was just a calibration exercise, but also to reduce the influence of temptation and time preferences. So I'm offering a quite high interest rate here. And lastly, this match should also help make this not an irreversible decision, in the sense that you can take the money from the interview and then also later deposit it in the account, but you cannot receive this 20% match. Okay, and so with this design, I argue that I can hold constant all other factors that influence savings decisions, importantly transaction costs, because people sit in the interview, everything happens within this interview, and I can really focus on this physical transaction, the only transaction I want to study. And importantly, also maybe to point out that there is no inertia in decision making here at place, given that everyone is taking an active decision. So that's very different from these default studies where people are, where not everyone is making an active decision. Here, everyone takes a savings decision. So I have my savings decision subject to experimental variation, and then I have all this interview data that I collect. I collect a few more survey rounds when people receive the match 4 weeks after the experiment, and then I can link all this to administrative weekly savings data. I have 5 local RAs who conducted 300 of these individual interviews and 31 of these borrower center meetings, and we used tablets to register the data, and conducted this in semi-urban and rural areas in 7 different cities in the Laguna province on the main island of the Philippines. And this experiment has the standard preparational features of field studies. So just to fix ideas, this is how it looks like. So we have the microfinance client. So she hands back the money that she wants to save to my enumerator. And importantly here to note, they're both women, and that's not a coincidence. So most microfinance clients are actually women. So I will have an all-female sample, and also my enumerators are females. So there won't be any gender effects in this paper. So are there any clarifying questions regarding the design at this stage? Okay, then I guess I continue. So before I go into the main results, let me briefly show you the balance table that also gives you an idea of what population I'm looking at here. So here I'm showing you the means of the people who receive 300 pesos and who only say the amount that they want to save. And what is most important to point out, so most of the people receive their income in cash, so about 90%. And also most of these people believe that their savings are safe in my partner's savings account. And so I'm working with a trusted organization. Looking at the administrative data, so most people do have some savings in their account, but on average, those people are rather poor. We have only a fourth of the sample being connected to running water. Now for each of these variables, I run separate regressions with the treatment dummies to see whether anything is off. And here I would argue that there's not more imbalance than what you would expect from running multiple regressions. And also the F statistics show that jointly there is no difference in these treatment groups. Okay, so now the main results. So what do people save? Remember, people receive on average 400 pesos. So here I combine, or I pool the treatments of 300 and 500 pesos and only look at these two main treatment groups. So the cash announce group that say how much money they want to save. And here out of their 400 peso, people on average save 168. So what happens if people need to hand over the money that they want to save to the enumerator? Nothing happens. So on average, people save exactly the same. So it does not matter whether they need to give the money back to the enumerator or whether they just say how much money they want to save. There is no cash in hand effect here on the savings decision. Now, is that coming from a particular part of the distribution? We can look at this real quick. So how to read this graph is here I have 11% of the people in cash announced in this gray bar who don't save anything, and I have 10%, so very similar, similar fraction of people in the cash in hand group who also save nothing. And you see I have this distribution of amounts where people save. There's some very clear focal points, but when I test these distributions in terms of being statistically significantly different from each other, they are not. So maybe to point out as well that people appear to be saving the same amounts even if they don't have the bills in their hand. So that really means that showing them the bills in the beginning actually helps create the similar mindset of how people think about the savings decision. Now also when I look at these two income treatments separately, I don't see any effect of the treatment. Reassuringly, those people who receive higher amounts, they also save more, which is in line with the literature. So here I would say people don't do crazy stuff in this experiment. Given that this is a null effect, I should briefly mention the minimal detectable effect size. So overall, I would be able to see a 41 peso difference in the mean amount that people save. So that's 10% of the average earnings, or a third of the standard deviation of what people save. Now, depending on what literature you are working in, you might find this a really big effect, but what I do in the paper is I benchmark this effect against other experiments in the pain of paying and endowment effect literature, and here I'm well in the range of effect sizes that those papers show to be significant. I also use a model selection algorithm to show that there is no treatment effect heterogeneity, further supporting the idea that there is no effect. But I can also show that there is ecological validity in my experiment, in the sense that what people save in my experiments, or those who save more, they also have a higher savings balance in their real life account. I can also use the administrative data to establish that there is no selection into coming to the session when we conduct the experiment or in participation. Now, the main question, and I have a detailed discussion of this in the paper, is like, why don't I see an effect? And there's two main points that are different in this paper as compared to the rest of the literature. The first one relates to the design of the sample. Given that I have a high stakes environment and I have a large additional incentive, maybe if this cash in hand effect is rather small, it's being washed out by these large stakes when people actually think harder about the decision. My sample is different. I think this is actually the relevant sample to look at for this question. But of course, those are microfinance clients. They mostly only use cash, and you might think that this reduces the effect as well. So overall, I would say that I provide a clean but lower bound estimate of this cash in hand effect in the field setting. I'm running out of time, but let me briefly point out that here, the other thing that's different in my paper is I'm looking at savings. And while savings also, or savings into these accounts in the setting also entails physically handing the money away, it does not change the ownership of cash, right? So I still own the money that I put in the savings account, and that's not true when I spend money. The money is usually gone. So that might change how people think about the transaction. And I have a more detailed discussion of this in the paper. So just to briefly conclude, I propose here and test this cash in hand as a new explanation for why people save little in their savings accounts. And I use a very controlled setting with both internal and ecological validity, looking at a real life transaction in a comparatively large and, as I would argue, very relevant sample. And in this setting, cash in hand does not influence savings deposits. And this is a puzzle, I guess, for behavioral economics and consumer research. And given that I didn't set up the paper to test the reasons behind the null effect, we will need more research to study the subtleties that lead to these differences. However, for development economics, I think we can say it's good news. There is no additional bias that we need to worry about and create intervention around. So I will stop here at this good news and hand it over to Laura, who was so kind to agree to be the discussant, and not only will make some interesting points now, but also already sent me amazing comments on the paper. So thank you very much for this.
Thank you, Lisa. Now Laura Schechter from the University of Wisconsin-Madison will provide their discussion points.
Hi, give me one second, sorry, to get set up here. Okay, can people see it and hear me?
Yes.
Yeah, awesome. Okay, thank you so much, Lisa, for that great presentation and a super fascinating paper to read. So as she said, Lisa looks at, does having cash in your hand compared to knowing you're going to get the cash but not having it yet lead to people saving less? And the answer is a definitive no. Normally, if you think about people who have cash in their hands saving less, you might think it's because they have faced temptations or transaction costs or inertia. But Lisa has a super clever design which basically holds all of those constants so we can isolate the pure cash in hand effect. Kind of difficult for Lisa, when you find the null effect, you have to argue pretty strongly that what you're estimating is a precisely estimated zero. And so as she said, the minimum detectable effect size is 10% of the experimental earnings. So where does that come from? So she said the average earnings in the experiment is 400. Of that, people on average deposit 165. And then the minimum detectable effect size is 41 pesos. And the actual effect is this really tiny 4 pesos, that people with cash in hand on average save 4 pesos less than the people who just know they are going to receive the money in the future. So the 10% of experimental earnings, this minimum detectable effect size, comes from dividing the 41 by the 400. But if I look, I would normally think about that by dividing the 41 by the 165 and saying that the minimum detectable effect is a 25% change in deposits. And to me, originally, that sounded quite large. But then I thought, well, let me look at some of the savings experiments that have been done in development, not necessarily with cash in hand, just savings in interventions in general, and see what type of effect sizes they find. This was just the assortment of papers I found on a brief run through. And actually, I was surprised to see that the effect sizes many of these papers find, all except one, are significantly higher than a 25% change in deposits. So in the end, I was convinced that Lisa's minimum detectable effect size was pretty small, and she was powered to find effects in the range of things that have been found in the development literature. She benchmarks it against more the behavioral literature in the paper. Okay, so if you find a null result, another thing you could do, which I think Lisa could do more of and she doesn't, is show that at least the randomization worked, that there was a difference between cash announced and cash in hand. And what you see, what I noticed here is that it looks to me like people with cash in hand are more likely to save amounts that are not purely divisible by 100. So there's obviously a lot of people saving 100, 200, etc. But for the cash in hand, there's way more people, more people saving 150, 120, 50. And so if you could show that, yes, this intervention did have an effect on something, it might also help convince that the experiment worked, people understood it, and that you are powered to detect some effects. Oops, sorry. Okay, so finally, why do we care about this research? One is that cash in hand effects are interesting kind of behaviorally, but the second piece is that we tend to think people are not saving enough. And so interestingly, one of the questions that Lisa asked in this follow-up session 4 weeks later is whether people wish they had saved a different amount in the experiment. And a big surprise to me was that more than half of the people say they wish they had saved less, which is not what we usually think. We usually think people regret not saving more. That suggests that commitment devices and reminders are not going to be very effective if people actually wish they saved less. So what does this mean? It suggests that poor entrepreneurs in the Philippines either ought to be saving more but just have low financial literacy, or it suggests they're not actually under saving. They can invest in their business enterprise and perhaps have higher returns than if they were to invest in a low interest bearing account, and maybe they ought not to be saving that much. And so it makes me think maybe, at least in this type of population of entrepreneurs, we should be rethinking our focus on behavioral biases limiting saving. But that's not for Lisa to do, that's just for thoughts for the future. Anyway, I will stop there. So thank you.
Perfect. Thank you so much, Laura, for your discussion points. Lisa, would you like to take maybe 30 seconds, 45 seconds to respond?
Yeah, so thanks a lot again for the comments. They're very helpful. And so maybe just in terms of did the intervention work? So it's a standard intervention used in many different settings. For the behavioral literature, and I agree that maybe I need to make this a bit more salient for development or more development-oriented audiences. And I actually do see some effects on some margins that would be interesting to point out maybe a bit more. So, for example, I see that those who have cash in their hands from the very beginning, they report higher cash incomes. They think that they will receive, or they will have more cash at the end of the day. So there seems to be something where people believe they're richer now that they have the money in their hands. But there was nothing that I kind of pre-registered, so I didn't want to push this too much, but it seems that there is this effect that people do respond to having the cash physically present.
Perfect, thank you. We have 1 minute for one question, and we have a question from Stephanie Hager. They say, are there treatment differences in survey responses 4 weeks later? Example given in CIH, cash in hand treatment, more likely to state that they wish they had saved more or less.
No, so I don't see any differences in the end, and I think that would also be a bit worrisome if I don't find an main effect in the experiment, and then 4 weeks down the road, people would be different. So I don't see any differences in this follow-up.
Okay, perfect, thank you. We are out of time for the first presentation, but if there are more questions, we'll get to those at the end during the after party. Now I'll have Ian introduce our second speaker.
Thank you so much, Biller. I have the pleasure of introducing our next speaker for today, who is Mira Fischer. Mira got her PhD at the University of Cologne in 2018 and is currently a postdoc at WZB Berlin. Her work is mainly on education economics and behavioral economics, behavioral policy making, and the intersection thereof. And today she'll be presenting her work on pardon me one moment, 2 field experiments on self-selection, collaboration intensity, and team performance. So Mira, whenever you're ready, you can take it away.
Thank you, Ian. Thank you for the very kind introduction, and thank you very much for allowing me to present here. It is an honor to present here. So let me just share my screen with you. Second. All right. So what I'm presenting today is a field experiment that I ran with Rainer Rilke and Burçin Yurtoglu. So it's actually 2 field experiments, and this is also how the project evolved. We first ran one study in one semester, and then when we saw our data, we thought it might be interesting to repeat the whole study, but change one aspect about the study so we could answer an additional question. So what we are interested in here is teamwork and how we can improve teamwork. So why would we be interested in teamwork? Just a second, let me set my timer. All right, sorry. So teams have become more and more important over the recent decades in all domains of work life. For example, in entrepreneurial ventures, in medical practice, in research. And what we can see, for example, in research, team sizes have increased on average in science and engineering and the social sciences, not so in humanities. And what you can also see is that teams are getting cited more often than single authors. There is a literature in economics that is interested in how to improve team performance, and it has mostly focused on incentives and how to design team incentives, on bonuses, tournament incentives, rank incentives. And as we can see here, for example, in the Bandiera study, so what these studies do is they argue, as in most organizations that use teams, our study uses team composition that is endogenous. So these studies do not explicitly study team composition. And for several reasons, we thought it would be very interesting actually to study team composition. And so when we looked at the literature, what we found was actually this one paper by Chen and Jigong. And so they were using self-selection versus random assignment. And we thought this study was very interesting. And we implemented something similar in our setting. We had the opportunity to run this field experiment in a classroom. And so what they find is actually that self-selected teams perform better than randomly assigned groups. And they had a third treatment where they were trying to optimize or use an algorithm that would maximize the skill complementarity of groups. And what they found is that actually self-selected groups perform just as well as those groups are assigned by the algorithm, and that self-selected teams choose people from their network and exert the highest effort of all the three treatments. And so what we were interested in is actually, or we thought there's actually two things that could matter for you know, how self-selection affects team performance. One is team composition, and the other one is team motivation. And there's actually another related study that we learned about actually only last year that has not been published, and it's not online. They are actually doing something that is quite similar to what we're doing, but importantly, so what they are not doing is they are not looking at how teams form, and also they don't formalize how they vary the task. So based on the study by Chen and Gong, we ran a second wave where we varied the task, and I will explain shortly what this allows us to address. And so this paper by Darlander, what they are doing is actually they are also varying the task, and they find that self-selected teams perform better when the task is implementing a solution to a given entrepreneurship problem, and they perform worse when the task is producing an entrepreneurial problem and solution and then implementing it. So what is not clear here is actually how these tasks vary and how we could formalize this variation. It's also not clear, you know, what explains this result. This paper is silent on this. And what we kind of do in this study, we're trying to improve on both of these studies. We're trying to study the team assignment or the self-selection that is going on, and also how this affects team performance in different tasks. And we also try to formalize why we think it affects this performance. So our research questions are: how does self-selection affect team performance? Does the effect hinge on the type of task? And if so, why? So what we know from the literature, also from the broader literature, is that when allowing people to self-select, people tend to choose people they like. And in these cases, they have higher levels of trust and invest more effort and resources. We know this also from lab experiments. When people, and they also choose to, you know, to match or then assortatively match on certain preferences, personality traits, and abilities. So what we expect of self-selection is that it increases the motivation of teams on the one hand, and on the other hand, that it affects the distribution of abilities across teams. So we expect that self-selection actually leads to teams that are more homogeneous within teams, but it also leads to more heterogeneity between teams. And we therefore, you know, expect that whether self-selected teams perform better than randomly assigned teams should depend on two things: the collaboration, the collaborative effort intensity of a task, and the ability intensity of a task. And just as an illustration, you can think that the score that they get, the performance, depends on their abilities in some ways and on the effort that they invest. And what we're going to vary in our two tasks is the effort intensity. So what we're trying to keep constant across both tasks is the ability intensity, which in our task is likely some sort of maximum function. So if one of the team members is able to provide the solution, the skills of the other team member don't matter that much. While in the other task, we have the same type of ability that are required, but they are also required to collaborate and invest effort. And then depending on what weights these two components have in the production function of the task, we expect the score to vary. So we're expecting that if you have teams that are self-selected, and then you get, for example, the high ability people clustering in certain teams, and other teams do not have any high ability people, this would lead, in this maximum function would lead to lower average team productivity than having the high ability people spread out more over teams, which is what we expect in the random treatment. But this effect, this advantage of the random treatment should be reduced by this ability advantage, this motivation advantage that comes from being able to choose your team partner. However, how large these two weights are, we have no ex ante expectation about. We just what we expect is just that there is reason to believe that if a task is only highly ability dependent, there might be a motivation, there might be an advantage for randomly assigned teams. This is also what the literature would tell us. And when we then add an effort dimension, this advantage should be smaller. So that the treatment difference should be smaller in this more collaboration intensive task. So our study setting, so we have participants that are bachelor students in the selective business school, and they take a class in the second term of their first semester. It is an introductory microeconomics class, and the final grade in this class is determined by the individual exam performance that makes up 70% of the final grade, and 2 team tasks that each count 15% towards the final grade. And the class is taught in 2 groups by the same professor with the same curriculum. And just our timeline and data sources. So what we have in our setting is we have data from the business school's administrative records. We have information on the high school GPA, and also on the admission on the admission tests that students had to take in order to be admitted to the program. Then from our experiment, we have results on team task 1, team task 2, and the exam. And after the intervention, we have a survey that asks for the course quality, teamwork quality, performance beliefs, social preferences. And this study was like a natural field experiment, so students were not aware of it taking place. The survey was like a typical survey that is being included in order to evaluate the course. We added some questions to that survey. And we had permission from the school's management to run the study. And students also, in this business school, they sign the study agreement that says that their data may be used, it may be used for improvements in teaching. And since the management of like the teaching department were fine with the study, we could then just use the data and also link the data. So the experiment took place, as I said, in the compulsory microeconomics class in 2 winter semesters. And students were randomly assigned to one of the 2 groups taught by the same professor within each semester, within each cohort. And one group of students could freely choose who to work with on the team task, and the other group was, and in the other group, students were randomly assigned to teams of 2 to work with on the team task. In the first wave, in the first experiment, both team tasks were written tasks, and students had to submit solutions to microeconomic problems. In the second wave, the second experiment, the first team task was written. It was identical to the first written task in experiment 1. And the second team task was a video recorded presentation to microeconomics problems. And it was like the cognitive skills that were required were very similar to the written task. But what we required here was that the presentation could take a maximum of 5 minutes. And also importantly, we required that the presentation is distributed evenly between team members in order to make it necessary for students to collaborate, in order to increase collaboration intensity as compared to the written tasks where we could not observe who was providing the solutions. And all tasks were graded for correctness. So also the presentation task was just graded for correctness by a teaching assistant blinded to the study. So the teaching assistant wasn't aware of a study going on either. So in total, we have roughly 400 students and 200 teams, and about 50 students in 50 teams in each cell. And the treatments were balanced with respect to admission scores and GPA. So coming to the results, so how does self-selection affect team performance? What we see is in the first written task, we see that the randomly assigned teams were doing better than the self-selected teams. In the second team task as well, and significantly so. There doesn't seem to be a time trend. And in the exam, we can see exam performance is not affected. So there's no, doesn't seem to be spillover effects from the teamwork on the exam. It also indicates that the professor, did the same in both classes. So for our study, it's actually, makes it more plausible and makes the results stronger that we find no effect on the exam. What we then did is we ran the second study, and we asked, does the effect of self-selection on team performance hinge on the type of task? So this time we had first the written task from the first wave, and then we had the presentation task. And what we find here is actually, we find the same result for the written task. So we are reproducing the same result. And then what happens is very interesting. So the performance difference flips, so the effect flips. What we expected that the difference would get smaller because of the advantage that you get from collaboration. And it seems to be the case that collaboration in the second task is so important that it outweighs the disadvantages that they have with the overall skill distribution in the self-selected teams. And then we find the same again for the exam. So this is the central slide of this presentation, also the central graph of the whole paper that shows essentially if we give them written tasks, we are producing the same result in two different cohorts and also in the same cohort over time. If we then add this collaborative component to a task, the result is reversed. And this difference is, I think, marginally not significant. But I think the p-value is 0.15 or something. So what we find is self-selected teams perform worse in the written task and tend to perform better in the presentation task. And the next thing we do is we ask why. And we look at the effects of self-selection on composition and behavior of teams. So what we do is we look at whether they are matching on abilities and gender. And what we have here is we are looking at so the random treatment and the allocation of people to teams that we got. And we see that it's very similar to this hypothetical random, like a simulation. It's not significantly different. And what we then see is if we look at the self-selected teams, they tend to be significantly more similar. So the distance between the abilities is smaller. And they also are significantly in both the GPA and the analytical test, and they also tend to be significantly more similar in terms of gender. So they tend to match on abilities and on gender. And another thing that we were interested in that we elicited in the questionnaire was prosociality. So we gave students the opportunity to make a donation. So it's like a real incentive that we gave them, and we observed how did we observe their decision in the survey. And what we see here is actually, so first we see that if you have a higher GPA, you tend to get a partner with a higher GPA. And if you are more pro-social, you also tend to get a partner with a higher GPA. The admission test, we find no significant relationship between these different variables, so it doesn't work. And then what we find interestingly, if you have a higher GPA, you tend to get a partner who's more pro-social, and if you are more pro-social, so if we here control for more stuff, we find this to be weakly significant. So there's also weak matching on pro-sociality. So the last question that we addressed is, what do self-selected teams do differently? And we had survey questions, and we just looked at differences in answers. And what we see here is, to some degree, what the self-selected team said. They tended to agree more with the statements. We communicated a lot, we helped each other a lot, both team members exerted effort, both team members contributed equally. And we do not find that they are reporting different experiences in other dimensions. So it really seems to be that it is the collaboration that changes, not the other dimensions of the experiences. So my last slide. What we find is that self-selected teams perform worse in the written task, that is low in collaboration intensity, but tend to perform better in a presentation task that is higher in collaboration intensity. And self-selected teams are more homogeneous in terms of abilities, gender, and pro-sociality, and they communicated more and collaborated better. So this is what I wanted to say. Thank you very much.
Thank you very much, Mira, for that presentation. We'll now turn to Roy Chen, who is at the National University of Singapore, for discussion.
All right, thank you very much. Can you hear me? Okay, great. So I don't have any slides, but I do have several things I would like to talk about. Thank you, Mira, for this very interesting paper and excellent presentation. So in this space regarding, when you have collaboration and teams and group projects, the literature has generally found that letting people choose their own teams improves group performance. But I really like this paper for the nuance that it adds, that the task does matter, right? Whether the level of collaboration required in the task does seem to have an effect on whether letting people choose their own teams improves the performance. And so that is a very interesting result that adds a lot of nuance to the previous studies. The other thing that I really liked about this paper was the fact that you were able to obtain these objective pre-experiment ability measures. Having these, I think, was a very important in establishing some of your results and looking at how people with different abilities, how they interact, and how important that is. Okay. So some things that I think that would be interesting to think about and perhaps, perhaps improve in your paper. One is about the design. So in your experiment, you have these two experiments, and each experiment has two tasks. For the first experiment, both the tasks are written, and these are the low collaboration tasks. And you find a very sort of convincing result that one of the groups that are not self-selected do better, okay? But when it comes to the higher collaboration task, the video task, you only see that in one of your cohorts in experiment 2. So I think that one thing that you'll have to think about is, is this enough data for that result? So especially since that you only have a p-value of 0.15. Is this result sort of convincing enough? You only see it in one cohort, and it's unclear whether sort of, I'm not sure that this is, I'm not sure if it will be replicable. And so this is something that you'll have to think about. When it comes to, and sort of a similar thing is regarding the way that these projects were graded. So you have one TA, essentially, one grader that grades all the projects over both experiments and all the tasks. And so I think that this is going to be sort of, I think it would be interesting to see, are your results sort of particular to this grader, right? Mm-hmm. And so I think it would be useful to, I think, given the data that you have, I think you have, since these are video projects and written responses, I think it would be interesting to sort of get some other people to regrade this and see, you know, look at inter-rater reliability. Do you get the same results with other raters? I think that would make your results more robust. Okay. And so one thing I would like to see in the paper, just discussed a bit more, is about how you obtained these objective measures. I think that I would like to hear more about sort of the hurdles and the privacy issues that you encountered when obtaining these, and sort of how you navigated that. Just briefly, I think that would be useful for, you know, even just for future people who want to do things in this vein. Okay. And another question I had really is about, you know, did you debrief your subjects? You know, this is sort of all sort of ethics related, and, you know, these people don't know about this experiment. I would like to sort of know a little bit more about that. When it comes to the analysis in your paper, I think that one big thing that you could add that would improve improve your findings is looking at the characteristics of the pairs and looking at how those characteristics predict performance. For example, you know, you actually set this up really nicely. You have this sort of measure in various dimensions of, you know, the difference between the two people in a pair, right? The difference in ability, difference in gender, and so on. And you only use this to look at sort of how the teams compose themselves, team composition. You never use that information to sort of predict the performance. And I think that would be a really interesting addition. So look, for instance, you might find that two people of low ability do better in some situations than one person of high ability, one person of low ability, right? Maybe similarity in these ability measures or other measures might predict better performance. And I think that would be an interesting thing to examine. Okay, that's my 5 minutes. So thank you very much.
Yes, thank you, Roy. Thank you very much for these great comments, and also thank you very much for agreeing to prepare the comments also at such a short notice. So let me maybe start with your first comment, your first question. How much time do I have? Something like 3 minutes, right?
Yeah, about 2 minutes remaining until 11, so take it away. Okay.
So the point that actually we have less data on this presentation task, that's true. We are repeating, or we have this written task 3 times, and then we only have the presentation task once. So we have for this task, we have 50 teams in the random and 50 teams in the endogenous treatment. And the treatment effect is significant at the 5% level. So what we could do is, I guess, we could look at power. So the treatment effect is, I think, 0.5. So looking at the exposed power would probably be interesting. Given that the treatment effect is quite big, it might actually be that the power is not that bad, but I totally agree. So we have more evidence for the first result than we have for the second, simply because we have less data. Your second point, the grading, one grader. So we have this teaching assistant who is grading throughout the experiment, is not aware of the experiment going on, and has been working in the same position for a couple of years before. And so for consistency, we didn't want to mess with the way that things were being graded. But I very much like your idea of actually looking at what this grader did in detail. So the instruction was, of course, always rate for correctness. but what how consistent the grader was, I think, would be very interesting. And we could indeed give you know, the answers to the tasks, the written task, and also the video presentations to another grader, and then look at whether they arrive at a similar rating. So how did we obtain the objective measures? So what I can say is that indeed this is usually quite difficult to get the registry data from universities, and I know this from my own experience. In this case, we ran the study at a private business school, and students had this contract in place that actually had this one paragraph about the, you know, agreement to the data usage, and this made everything much easier. So we just linked the data, and we had the dean of studies who agreed with the study, and so we could just use the data. So in this case, it was very easy. In other cases, it can get very difficult and prevent you also from, you know, running such a study. And we did not debrief subjects. So until now, they don't know that the study was going on. And analysis, yes, you made some very interesting suggestions, and I think we should definitely look at this, at how this distance, the distance between the abilities, for example, and the higher and lower ability predicts team outcomes. So I think my time is up, so thanks a lot.
All right, thank you so much, Mira.
We will basically just move to the party, the after party at this point. Yeah. So if we have up to 30 minutes for free-form discussion. For the attendees, if you would like to ask questions, the way it's set up as a webinar, we have to unmute you. And so if you raise your hand, if you go to the participant logo and click, you'll be able to raise your hand, and then we can see that and move you, basically allow you to talk. So, it's very hierarchical the way it's set up. So there's one raised hand, right? Yingzhi, yeah, okay. So go ahead, Yingzhi. I see. Yingzhi, are you there? Okay. Let me promote her to be a panelist. So. Okay. So while we wait for her, I have a question for Mira, which is the production function that you set up is P times max AIAJ. So this is the ability component, and 1 minus P times QIJ. This is the effort component, right? You didn't define QIJ, is it the effort? You're muted. Yeah.
Sorry, yes, that's so the QIJ, that's the collaborative effort that people are investing together in the presentation. And this is, of course, it's just a sketch. So it's you know, with Roy's suggestions, I think we could get closer at, you know, looking at what the true production function was, but this is how we set it, or how we thought about the tasks, and this is how we set them up. We wanted the ability component to remain constant across tasks, and then we wanted to add some collaborative effort component.
Yeah, yeah. So I think in general, it makes sense. It probably for the microeconomics problems, your first task, it makes a lot of sense to think that the max ability, you know, if and a bad student, or it max a good one and can solve the problem. For the presentation, would you say that there's more complementarity in the output, sort of complementarity of effort?
Yes. So what? So certainly, since both people have to present their part, they both kind of have to understand what they have to present. You know, you could also look at, you know, complementarity and make the production function more difficult. So what we thought about was actually also in this case, one of them could actually come up with the solution, and the one person would have then to teach the other and they would have to actually sit together, and the one would have to teach the other and make sure the other could also present their part. So we captured this in this effort component.
Yeah.
Since we don't have a lab experiment and we cannot impose a production function, we don't really know how this task works. But what we wanted, and certainly, in this case, the ability of the less able person also should matter to some degree, for at least understanding, how to, what the other person teaches them. So it's just a great simplification, and it's probably wrong. It's probably, not capturing everything that's going on. Yeah, so then you could think about skill complementarity, and possibly you could also uncover that complementarity if you look deeper into the data. So I think that's a very good comment. It's like something, it was like a very simple idea, and we tried to get as close to it as we could.
So I think that in the end, I like the point that the team performance depends on the type of tasks you have at hand. The question is whether you can actually, depending on the degree of complementarity, you can have a cutoff, excuse me, condition. When would you expect team performance, self-selected team or homogeneous teams to perform better versus more heterogeneous teams? Yeah.
Yes.
Right. And I also want to echo Roy's point, which is in content analysis, which is your video, there is a subjectivity. The standard practice is to have multiple raters, all blind to the hypotheses, and evaluate, taking, let's say, the median raters rating, and then at the inter-rater reliability. Have more than 2 raters, they're sort of, depending on the number of raters you have, there is a well-developed set of metrics for evaluating these evaluators.
Yes, I totally agree. Maybe to come to your first point, or previous point, this cutoff condition. Yes, I think that's a very valid point, and I think in order to actually look at this, you would need to have more tasks that vary in this collaborative component. What we could do is actually look at, for example, whether the distance controlling for the skill level, whether the distance in the skills between the two predict the outcome, and then have a squared term and look at whether there's some sort of optimum distance, and look at whether the relationship reverses at some point, or the treatment effect reverses at some point. Then about the one rater, so that's true. So we are aware, of this, this question, has come up before, and usually when you have something, subjective to be rated, you at least have 2 people to look at, indeed, this inter-rater reliability. So in our setting, we didn't want to introduce an additional person, since all the other tasks were just rated by this one person. We didn't want to introduce a second person. And also, what we didn't want the person to grade was something that was more subjective, something like the flow of the presentation, and the quality of the charts they were using, and so on. So everything that we want. So what we wanted was, to evaluate the exact same dimension that was to be evaluated in the written task, which is just whether the answer is correct or not. So this is what we think reduced this problem of subjectivity that you have in the presentation. Yes, because indeed, the presentation, there is like more subjective quality components, but we wanted to get rid of them specifically by instructing the rater just to look at the objective component. And I think what we actually should do is we should give the presentations and the written answers, we should actually give to another person, or maybe 2 other persons, and look at what they are doing, and whether what they are doing is similar and we get the same results. Thank you very much.
Yeah. So I think in the order of Yingzhi had a question, and Marie Claire also have questions. Go ahead, Yingzhi. We cannot hear you.
Hello. Yeah, I like your presentation a lot. I have a question about the first experiment, which is you repeat the same task twice. So the reason to repeat the same task twice, is this because to compare with the second experiment where you have two different tasks?
That's a very good question, thanks. So what allows, so having two written tasks in the first wave, what it allows us to do is to look at ordering effects. And we find no ordering effect or learning effect across these two different written tasks. This also reduces, the concern that maybe the result for the presentation task might be driven by some ordering effects. And the first wave, where we had very similar tasks and we find very similar treatment differences in both tasks, suggests that these ordering effects are not existent. But there was, of course, also a practical reason. So why there were two written tasks? It was also that this was the default in this. This was, was already there in this. So we just used it and we tried to make the best use of it. So I agree. There are reasons, there would have been reasons maybe to have another presentation task in the first wave and maybe switch the order. Would have probably been interesting.
Experiment before running either of them, or you design the second one after running the first one?
Can you repeat the question, please?
So, like, did you design the second experiment after running the first experiment, or
yes,
both experiments?
Yes. So we pre-registered both waves, or both experiments, but indeed we looked at of the first wave and we thought about, what can we contribute to the literature, what can we add when we repeat the same study? Do we just want to collect more observations, or do we actually want to address an additional question? So this is also why we call it two experiments, because we came up with the design consecutively. They're separate figures.
I once ran a very similar field experiment where I also assigned students into different groups. So the way we did that is one treatment, the students are assigned with their close friend, and before the class gets started. And the second treatment is students are assigned with some other student in this class, not their close friend. And then we actually had a team as sort of a commitment device for them to complete the class assignment. And in that situation, we did find that the teams that form with friends perform better than the team.
That's interesting. That's interesting. Is the study published, or is it available somewhere? Could you send me a link?
Not published yet. It is still I'm still doing the data analysis, but I think the sort of fit into which is the task that I have is more complementary. Therefore, then what you find is if the task needs higher complementarity than the random assignment is better. Yeah, so in my case is the task needs a lot of complementarity, but then the friend assignment is better. Because again,
repeat the last sentence, please. The connection is not very good, I think. Could you repeat what you last said, please?
Yeah, I said in my case, the task requires a higher complementarity. The friends treatment in my task actually I think they tend to be more responsible or reliable towards their friends.
So what kind of task are you using? Is this a task where pre-writing is possible, so you don't observe the separate contribution?
Yes, the task itself is so you write an exam preparation plan, and if you submit your plan, you get 1 point, and if you also submit the plan, you get an extra point.
Interesting. I would love to read the study once it's ready. Could you send it to me?
Yeah, we can discuss this offline.
Yeah, or we can get in touch later. Also, we can discuss more if you like. Thank you very much.
Yeah, we should move to Marie Claire.
Okay, hi everyone, and thank you for the two very interesting talks today. I have another question for Mira. With self-selection, could they have done better? I mean, in terms of matching, could you estimate the proportion of people who could have made a better decision by choosing another match? Or are there losers? Are there people who could have done better by choosing another match?
So you think, so to approach, I think that's a very interesting question. So I'm just trying to think about how to approach this question empirically. Would you compare, for example, two people who have the same ability and are matched with team partners of different abilities?
Of course,
and then look at which teams are doing better, and try to from the available pool that you have, given you have one stable pair, how you could reallocate this person, and then so I'm just trying to think about what the counterfactual is, how to run this simulation. So it's true that people, we observe assortative matching. So we assume that everybody, of course, wants to match with a high ability person, the highest ability maybe, if they are concerned just about the team performance. And the reason why we observe assortative matching is we think you get the highest ability person given your own ability. So people on average tend to end up, because it's bidirectional matching, they tend to end up with somebody of similar ability. So could you suggest a way to approach this question?
I don't know. I wouldn't have to think further about it, but I think it would be an interesting addition, because there are probably some people who are losing in this matching. And that would be interesting to not only report the positive aspect of this self-selection process, but also who is losing in this process.
Yes.
And whether perhaps the loss is very small, so it doesn't matter so much. But it would be interesting to find a way to say something about it, even if indeed you don't have the counterfactual, so it's difficult.
Yes, I think at least in this task where it is basically only ability dependent and not so much collaborative effort dependent, what we can say is that that those people who have below average ability, they would on average end up with somebody of higher ability if they had been randomly matched than if the matching is endogenous. So
yes,
I think something like this would be true for this task. For the other task, it then depends on on how much motivation the self-selection contributes, and then probably you would have a cutoff. You would have less than half of the people who are disadvantaged by the endogenous matching, I guess. Something like this. I think from the top of my head, I would think it goes something like this, but I have to think about it again. So thanks very much. I think that's actually a very interesting thing we could look at. Heterogeneous effects, because we're talking about education, and in education we're always not interested only in average effects, but also in heterogeneous effects, and who are the winners and losers. Yes.
Exactly. Yeah. Thank you.
Thank you very much, Marie Claire.
All right. So I have one question for Lisa, and in some ways also Laura, which is about the your experiment. So there's no treatment effect, but it is, my understanding is that it is sufficiently powered. And is it pre-registered?
Yes, it is.
Yeah. So I mean, so like, you know, so what's your thoughts about publishing venues? I've had an experience, which is the Journal of Development Economics sometimes contact authors based on their pre-registration. So they say, we commit to publish your paper based on your pre-registration without seeing your result.
Yeah, they introduced this, I think, after I ran this. So this rule at the JDE is rather new. But yeah, I would be very interested to hear Laura's opinion on this.
Yeah, I mean, I don't think you can do that after you've run the experiment. Those pre-registered reports are something that you can submit before you run the experiment, and then they'll commit to publishing it if based on your report, but you don't have to publish it there. You could publish it somewhere better. I do think you could make a bigger deal in your paper about the pre-registration, because I went to look at it and you basically almost do exactly what you said you were going to do. And you could brag about that more and show off about that more. I think you will have to do more to claim that this is a small, that your minimum detectable effect size is actually small.
Yeah, I think, and also experimental economics is having, oh yeah, so it's the same idea as the JDE, which is, we'll take your pre-registration and then based on the design, basically, and your pre-analysis plan, we'll make a decision, a conditional publication decision without seeing your result. I would imagine that given these initiatives, these journals would be open to publish null results.
Let's hope so.
I mean, what's your thoughts about publication venues?
So it's currently under review.
Oh,
so
okay, never mind. Yeah, okay.
I do have a question for Lisa. While I don't think we have any questions just yet from the audience.
Yeah.
So do you have, your subjects are microfinance loan takers who are entrepreneurs. Do you have any information about what proportion of their earnings come from cash transactions versus credit card transactions? I'm curious to see if there is any heterogeneous treatment effects based on how used to they are handling cash versus credit card transactions.
Yeah, that's a very good question. So actually, so the Philippines is a bit behind in this whole mobile money movement. One of the reasons I actually went there. But people have very little exposure to other types of cash, and there's a small fraction in my sample who does have other means of transaction available. But I think, so I didn't check, but my guess would be that it would be too small to see any differences in treatment effects there.
Yeah, thank you. I do have another question for Mira. So from my experience teaching experimental economics, what I find out that when they form their teams, groups together, that works better. And one of the reasons for that is that they can align, they can get into groups with people who have similar schedules. So I'm thinking your video video group assignment, do you think that maybe it played a bigger role? They had to come together more often to be able to prepare that video as opposed to writing part of the task, which you may be able to do remotely without meeting as often?
Thanks, Bilo. That's a valid concern. So I don't think it is actually a problem in our case, because these are first semester students who are only taking compulsory classes. So they don't have any choice yet. So they should all be following the same schedules. So I don't think that's a concern or a likely channel in our setting. But indeed, if you have more advanced students who then have lots of elective courses, then you can have, you know, time conflicts, and, you know, students might have less time when you randomly match them, because you get worse matches in terms of time. But I think in our setting, I think that's not a concern. Maybe we should say a sentence about this in our paper.
Perfect. Thank you.
Thanks.
All right. So, any other questions from the floor? If not, so we're resuming next week, next Wednesday. So thanks to all the presenters and discussants. Excellent papers. So bye,
Thank you very much, everybody.
Yeah.
Thank you.
Thanks. Bye.
Bye.